In this chapter, we're going to introduce two new functions for you. One that you've worked with before, and the other one is completely new. So let's take a look at the one that you should be somewhat familiar with, and that is the exponential function, f of x equals b to the x. Okay? Now there's some restrictions on b. b has to be greater than 0. The reason that b has to be greater than 0 is, let's think about trying to take -1 to the 1/2 power. That's basically saying square root of -1, and we know that that is the imaginary number I. So it's complex. So again, for these functions, we are just working with real numbers. And b could be 1, but we can't say that it's actually exponential growth, because if we have f of x equals 1 to the x, think about all you're ever going to get is 1. 1 to the squared is 1. Square root of 1 is 1. 1 to the -1 power is 1. And when we think about exponential functions, we think about either growth or decay. It's either growing exponentially or decreasing exponentially. And exponential for us is going to mean growing very fast. So here are 3 examples I want us to take a look at. The first one is a very basic function. And this is one that when we're doing transformations of these functions, you would always work with the basic 2 to the x or 3 to the x. And the bigger that b is, the faster it's going to grow. Basically, we're saying with f of x equals 2 to the x that for each unit of time or whatever, it doubles. So 2 to the first is 2. I'm going to jump down here to 2 squared, 4. If we had f of 3, that would be 2 to the third, which is 8. So you can see that for each unit that we increase by 1, 2, 3, we are actually doubling. F to the -1. Do you remember what a negative exponent does? It doesn't make the base negative, it flips it. So think of 2 as 2 over 1, and so 2 over 1 to the -1 power would be 1 over 2. And then anything to the 0 power is 1. And we talked about that last semester when we were working with exponents. Okay, let's take a look at our next example, 1/3 to the x. This is not an example of growth. It's actually an example of decay. So it decreases by 1/3. So if you started out with 9, then you would go to 3, and then you would go to 1, and then you would go to 1/3. So this has an exponential decay because b is less than 1. It's actually between 0 and 1. Remember, we don't have b has to be greater than 0. So anytime you have b between 0 and 1, you're going to have decay. And anytime b is greater than 1, you're going to have growth. And we'll talk more about that in class. Okay? So let's do this one. F of 1, so 1/3 to the first power is just 1/3. 1/3 to the -1, again, that negative is just going to flip it, so this becomes 3. 1/3 squared is 1/9, and 1/3 to the 0 is 1. Okay? Now, the last example actually has a transformation. Do you see this x minus 1? When we talk about graphs in class, if you know what 2 to the x looks like, then this is a shift. Which way? So when we evaluate this, when we plug in 1, this is 2 to the 1 minus 1, which is 2 to the 0, which is 1. F of -1 is 2 to the -1 minus 1, which is 2 to the -2. And what does that mean? It means to flip it. That's what the negative is going to give us, and then square it. So this is basically 1/2 squared, which is 1/4. Plugging in 2, we get 2 minus 1, which is 2 to the first, and 2. And this time 0 is not going to give us 1 because of the transformation. So when we actually plug it in, we get 2 to the negative 1, and again, that's 1/2. So that's the end of your video. You're going to have some questions mixed in and at the end, and we will see you in class later this week. Thank you.